Are you saying 30-ish or 300-ish, Kevin? All right, we're about to look at yours. Something's going on with yours. Ooh, I like that answer, Jay. At 6 inches is 370. Okay, so that seems to be the range. That should be all you need right there. And then you already have this here, and you should have that, Andrew. Okay, this is going to make things a little bit more challenging. All right, I want everybody to. Oh boy, this is going to be fun. All right, your set point. Listen up, listen up, listen up. Actually, Manuel, what numbers were you getting? I didn't see any numbers from you. You shouldn't have integral. Don't put what you see in my code. Take out anything that says integral. All right, I want everybody to change your number, your set point to about 370. Everybody copy that? All right, everybody change your set point to about 370, about 370. Cool. And then re-upload your code, and then see that you should get positive or negative numbers either way. Kevin, we're going to look at yours. Do you have anything plugged into A1 on your Arduino, Kevin? When I said set point, yeah, I meant this number right here. All right, what do you mean 360 is no scope, Gabe? I'm really confused there. Okay. Oh boy. Okay, so something's amiss. What am I missing? What am I missing? David, what kind of numbers are you? Uh, Wait, hang on. First thing first. Kevin's having issues here, so I got to figure out Kevin's problems. Kevin, are you getting any numbers higher than 20 for your IR? All right, put your hand approximately 2 inches away. Give me a reading. 6 inches away. Give me a reading, and then about 12 inches away. Give me a reading. Tell me what. Please, nobody else talk about other than Kevin right now, please. All right, thank you, Dave. That's all your comment. Kevin. right, so set your set point to about 370, Kevin. Okay, Manuel, what are you getting about 6 inches away? Approximately. High 300s. Okay, so you're in the ballpark there. Something's still amiss, and I can't figure out what. All right, so everybody can make comments again now. Let's continue on. I'll think about this in the back of my head. I think I'm missing the middle slice of code. Did you have the? Oh wait, what is the hell? What did I do? Okay, everything looks right on my end. Okay, cool. All right, let's move on, and I'm going to have to keep this problem in the back of my head. There's something's funky. I'll figure it out. All right, the next thing, or the part we're missing, that's the part we still got to do that. That it's not going to be the issue, but it could affect it. It's just not the same part. All right. Sorry, I'm just trying to think and figure out what the difference is at the same time. All right. So we have the EFT, we did the error, but we did nothing with this KP value. Now this KP value is nothing but a multiplication, a tuning variable, if you will. All right, and the only thing it's used for is to change the value of EFT to a proportionate value, because it's proportional. But KI, I'll explain all that here in a few minutes. We're missing the KP, and actually, to be honest, I'm not sure we're going to use it, but now I'm actually thinking we are going to use it. But we are going to code for it no matter what. Now, KP is a simple multiplying factor. How do we make a multiplying factor not affect the output? What can you multiply something by not affecting what it is? There you go. Most of y'all are getting it. Divide by the same amount is true, but if you divide by the same amount and multiply by the same amount, what are you actually doing, Kevin? Canceling it out. You're not quite canceling it out. If I take 12 and then multiply it by 5 and then divide it by 5, what am I actually doing? You got it right, David. I thought David, Jay, Andrew, good job. What number is 5 over 5? How many times can 5 go into 5? 1, exactly. So we're just going to set up a multiplying factor and just set it equal to 1 for right now. That's all we're going to do. And the way you do that is simple. We're going to add a double KP equals 1. And where do you think it's going in the code? Motors, void loop. Good broad answer there, David. You're not 100% wrong. PID stuff, you're not 100% wrong either there, Gabe. So we're going to add this multiplying factor to somewhere, to our output here. All right, so we're just going to say out equals Kp times error. So we're just multiplying error times 1, since it's not going to change it. But now the error values are making me really, really, really nervous, so I'll figure it out. All right, and raise your hands when you have all that. When you have the Kp value and you set it out equals Kp times error. Ignore that slide altogether. And we're ignoring that slide too. No, today's probably not going to be the last Larry the Robot day. We're not going to get through this code tonight. I can already see that. Yeah, you can upload it after you do that. It doesn't matter. You haven't really changed anything in the code by doing that. So the only thing we did is multiply the number times 1, so we're not changing anything. So yeah, you can upload it, but it's essentially the same code. Manuel, how you coming? All right. Are you talking about like get the program that's on the Arduino off the Arduino? Like if you didn't know what the program was, David? Is that what you're asking? There is, but you have to do assembly. You have to like get into assembly language. Which I don't even know how to do assembly language. All right. Anyway, do you have this Kp times error? Okay. So now on to the other part here. So now we're going to move it, make it a little bit more complicated, and we're going to look at what this symbol here. What is that symbol? A symbol for an awkward J. This is going to be the symbol for an integral. All right, and it's used for a lot of things, but one of its main functions is it serves for finding the area under a curve, or any curve. All right, and I'm going to try to, this concept of an integral is way beyond this class. Way, way, way beyond. This is calculus 2. But I have faith in y'all's intelligence and I have faith in my descriptive abilities, I am going to try to break down the basics of what a integral is. And I will let you know, just because I'm showing you this does not mean you know what an integral is. Integral is a huge concept. All right, let's try this though. All right, I want everybody to give me an answer. How do you find the area of this? So give me the formula to find the area of a triangle. Not quite, David or Jaden. Outstanding, David. Completely wrong. You're going the opposite way, Jaden. Good job, Manuel. Three, not 13. Good job, Gabe. I knew you'd come through. Who did not answer? Andrew, did you answer? Yep, you did answer. All right, cool. Everybody knows how to find the area of a triangle. Hopefully. Cool. All right. Yeah, it's 1/2 base times height. And I was looking for, I didn't care if you got the wrong answer, but if you didn't answer, I was going to take away all your points. But everybody answered, so good job. But this is the formula to find the area of a triangle. Now, why am I using this reference, or why am I using this? Well, because one, what I say that the integral is used to find the area under any curve. Now, curve can be a line or anything in a graph. If it is a continuous function, meaning it goes on and on forever, you can use a integral to find the area underneath it. All right? It doesn't matter if it's sine or cosine or some weird e to the x or something. If it is a continuous function, it means you can find the area underneath it. All right? And yeah, there's going to be algebra, but I'm also going to teach you one of the things about calculus here. So here we're going to look at the graph of y equals x. All right, it's one of the simplest graphs you can do. All right, so if y equals 1, what does x equal? I don't know what that was either, Gabe. So yeah, if y equals 1, x equals 1. If x equals 1, or y equals 1, x equals 1. If x equals 2, what does y equal? 2, exactly. And this goes on forever. So y and x are always equal. If y equals 318, what does x equal? 318. Good. Y'all can. I was about to say, Gabe. All right. So y'all get the simple pattern recognition of what an integral is. All right. So here, let's look at the integral of x. So I postulate the claim that using the theorem of calculus, I can find the area underneath this line no matter where it's at. All right? So what is x raised to? What, in this problem, what is the power of x raised to? The first, yeah, I've already said the answer, but good job, Dave. Yeah, it's raised to 1. Even though you can't see it, there's a 1 right there, right? So, even though it's not shown as power of 1. Now here comes the hard question. What is 1 plus 1? Get out, Gabe. Manuel, don't start. Not telling you. All right. Yeah, exactly. 1 plus 1 equals 2, right? Now I'm going to get my pen out so 1 plus 1 is 2. I can write 2 over here. I can write it over here. I can write 2 wherever I want to on this page. That's a 2 on crack. And this is a 2, 2, 2, right? All right. Simple. This can be a simple, just moving number to a different location. So the integral of actually x to the 1 is actually x squared over 2. And don't worry about the plus c. That's just saying constant. All right? So I took this 1. Get my pen out again. I took this 1. I added 1. And it equals 2. Easy enough, right? Now I took that 2 and then just moved it down here. All right? Now why am I doing all this? Because Newton told me to. What's the other guy's name? Isaac Newton and a guy named Leibniz. All of those because math. Because Leibniz said so. All right? Now, there is actually more to it than this. All right? This is just known as the power rule. He's not wrong. If he was wrong, Gabe asked what if he was wrong. If he was wrong, some other mathematician would have called him out on it. And actually, a few of them tried, and they all failed. So I skipped quite a few things here. All right, so this is just known as the power rule of calculus. When you do calculus, you will use this rule, this idea a whole lot. All right, a whole lot. Right? And I'm going to give another example here real quick. All right. So if I took the integral of, let's say, x to the 4th plus x to the 12th plus x to the 9. All right? Give you 1 second, Jay. Or not Jay, Gabe. Sorry, saw Jay there. All right, so the integral of this would be as simple as just adding 1 to every single number. So this is just 5 over 5, and then moving that down, plus x to the 13th over 13, plus x over 10 over 10. All right. Where's x to the 21? Stop it, Manuel. All right. What's your off-topic question, Jay? Or not Jay, Gabe. Not you, Jay. I'm sorry. I kept saying. I meant Gabe. You can't really type that awkward J, as Gabe's question is, how do you type the awkward J? And we're not talking about you, Jay. There's no symbol. Well, I think there is a symbol for it. You don't really type it when you do actual math with it. What kind of calculator do you have, Gabe? TI-89? Oh, well then. Like if you come here to Wolfram Alpha, I just type in integral here. It's going to take me to a page. Hang on, I'm going to show you this real quick. And then you usually just say, so if I want to do all that just put up there x to the 5th plus x raised to the 12th plus x raised to the 54th. You got to put parentheses around stuff. Parentheses, parentheses, parentheses. And that's going to equal, you might want to take a stab at it, x to the 55 over 50. Oh, what did I do there? Oh, I put a different value. X. There it is. And you get x to the 6 over 6, x to the 13th over 13. So it just added 1 to everything and moved it down. All right, let's move on. Running out of time here. All right. So how does this prove my point that this is finding the area underneath a curve? All right. Well, let's look at this graph again. If we start here at 0, and if I stop anywhere here on this line, so let's say 3, right? Is this not a right triangle? Does not look like a right triangle. It is, right? So I could say that I can find the area underneath that as 1/2 base times height, right? So the area of this would be 1/2 base times height. All right, so it's not 1. Actually, wait, is it? No. All right. Where's that? Shoot, now you got me off track. All right. And what is area 2? What is another thing to look at what area is? Area can also be the, whoops, I got my slides out of order. Area can also be the sum of all these squares in the middle. All right, so so if I add up, and these had units to it, if I add up all these squares here, right, saying that this is 1 square, this is 2 squares, this is 3 squares, right? Then what, 3, 4, it's like 4.5 squares. And that's what all this area here is. So it kind of, I want to throw this up here because this is more about what we're talking about. But integral can also be a summation. This is a summation, which is what we're talking about here. I know I may be losing a little bit on that, but bear with me for 1 second. So if the area of a triangle is 1/2 base times height, but if base is equal to height, in the case of y equals x, right? So the base and the height is exactly the same thing, right? So couldn't you say that base squared or height squared is, so it's like you say 1/2 base squared, right? So you could even say in this case, since x is our base, right? I'm just saying base squared divided by 2. Does that make sense? Sort of, kind of. So let me try this a different way. Let me do one more thing real quick. There you go. Gabe sees it. It is like a square after you, yes, exactly. Exactly, Gabe. There you go. Boom. You got it. Let me do I want to go into bounds? I'm not going into bounds. I don't have time to go into bounds. But that is what that symbol is representing. It is just representing the area underneath a curve. And a curve in this case is a straight line, which is absolutely fine. Actually, I do want to cover one thing real quick. All right, so here I'm saying that this starts at 0 and it goes to 3 here, right? And that's what I wanted to kind of briefly mention is here. So I can take those same numbers and go put them to here, 0 to 3, and that will give me the exact same answer. Because if you take 3 squared, I get, what, 9. If I divide that by 2, I get 4.5, right? Which would be the same thing as saying 1/2 the base 3 times 3 equals 4.5. All right, so that is the basics of calculus, or some of the basics of calculus. It's not calculus. Don't be going telling your math teacher at school that Mr. Pearson taught you calculus, and he's going to laugh at you when he gives you a problem. All right. Now that was the very basics of integration. The main reason why I wanted to go through that is I hope all of y'all stay in engineering, but a lot of people don't stay in engineering because they're scared of math. All right, that's what they're scared of. All right, and I just showed you calculus level 2 math. All right, hopefully that was not all that scary, and you can see that it's really not that difficult once you break it down. All right. All right, I got 3 minutes here. So back to the code. The integral is used as the sum of the error. This is the sum of the error plus the sum of the last error. But what is the last error? No, my teacher was not that nice. David, it took me forever to figure out some of the things in calculus and to break it down simple. Teachers like to explain things complicated. I don't know why. But what is the last error? The last error is actually the current error until it gets another error. There, in simple terms, it is the current error until it gets another error. All right, so that's it in the most simplest terms. Go ahead, try to code it. I'll wait. That's me waiting, by the way. No, it's not. I'm actually not going to do. Yeah, I'm not going to do it. Hang on 1 second here. All right, so first up, we know we're going to have to add this here. Go ahead. Jaden, why would you like me to stay over for 30 minutes? Let's clarify what's up, brother. So you don't need me to stay over? I can stay over, man. I just don't need to find out why. Well, I'm going to put hands down first. Raise your hands up when you have this little bit of code here. Oh, okay. Well, I'm actually, there's a reason. Well, I'll tell you in a little bit. I'll tell you after I get out everybody's hands up. And do me a favor, make sure you put this in the PID stuff. Put this in the PID stuff for me. Manuel, how you coming? Give me a few more minutes here, y'all. I know it's 8 o'clock. Give me a few more minutes. All right. Here is the last part here. Go ahead and add this, and I will end class at this point. All right, and kind of go ahead and say bye and log off after you get this. This code is not done yet, but I do want y'all to try something this weekend for me. Try to make your robot do something that based off the sensor. I don't care what it is. Don't change this code. Do not mess with this code. Use your own code. Do not change this code. But try to write another code if you have time and you're not studying for finals or writing essays about Mark Twain or adding up 6 plus 6 in your math class or whatever. I think that's what Manuel is doing, but I'm not sure. Yes, if you want to add something to it, that's fine. If you want to add the beeping thing, make it beep. If you want to add the push button, if you want to add there's a flex sensor in there. Flex sensor is just the analogs. Use the book, try to find the code for it, and see if you can make the robot steer left or right based off the flex sensor. Just try to make your robot do something. Probably not, Gabe. Gabe, you really want to know, there's all kinds of tutorials out there for it, brother. It's really not that hard. Well, if you actually are interested in engineering, get used to your best friend. You know what engineer's best friend is, right? Yeah, okay, that's true. Google and YouTube. If you're an electrical engineer, you got it right, David. Cool, cool, Mr. Gabe. I'm studying nuclear physics right now. Eh, hard is relative. Tell you what, here's my, if you really want to do nuclear physics or nuclear engineering, when you get into college and you take differential equations, when everybody's saying take the hardest teacher or the easiest teacher, take the freaking hardest. Because you need differential equations. You need to know that. There you go, Gabe. So yeah, I'm all right, somebody asked a question. I can't remember who it was. I'm stopping right here at this point because now I'm kind of worried about how that ruin your dreams, Manuel. Yes, you're allowed to leave. Quite a few, Jaden. A catwalker. If you have not sent me your email about what your choices are, make sure you send those to me. Anyway, what, not, you got me worried, man. What did I do to ruin your dreams, man?